All right, so today we are going to be reviewing our recursive sequences. I have two examples. One of them is going to be an arithmetic example, and one of them is going to be geometric. So example one and example two are right here. Now remember, for our labeling of sequences, our sequence, every term is called A, and they get subscripts. So this would be A1, then A2, then A3, A4, etc., etc. This sequence goes on forever or until the nth term. So that would be AN. Okay, so this is how to name a sequence term. Same thing over here. It would be the exact same naming structure. This would be A1, A2, A3, A4, all the way out to whatever value you want. AN. Usually we use N because that implies that this could go forever, which it can. Then the next question we always have to ask ourselves is, how does this grow? How does it grow? Question. And if it's growing like this one, 2 to 4, 4 to 6, 6 to 8, this is adding 2, plus 2, plus 2, plus 2. If it is adding, so this one is adding, whatever it's adding is the common difference, okay? Whatever is added is called the common difference. All right? And the same thing over here, I can ask the same questions over here. How does this grow? And here, to get from 8 to 16, I'm going to multiply by 2. To get from 4 to 8, I'm going to multiply by 2. So I'm just multiplying by 2 every time. So I am growing by multiply every term by 2. This value is called the common ratio. And that's really what is going to be the difference between these two equations. One has a common ratio, one has a common difference. If it is adding and it has a common difference, that means that this example is my arithmetic example. And if it is growing by multiplication or division, that is my geometric example. Now, if you wanted to know how to find the common difference, how to calculate, all you have to do is take a new term minus an old term, and that will equal my common difference. So for example, if I took my new term 8, the one that's right before it is term 6, so 8 minus 6 is 2. Or I could take term 4 minus 2, and that's also 2. Or I could take 6 minus 4, that is 2. So I can do that to any of these. Now, how would I calculate my common ratio? To calculate my common ratio, all I have to do is take my new and divide by my old. So that would equal my common ratio. So in this example, my new might be 16. So I could take 16 divided by the one right before it, which is 8, and that equals 2. Or I could take 8 divided by 4, that equals 2. Or I could take 4 divided by 2, that equals 2. So here I find my common ratio by dividing. And here I'd find my common difference by subtracting. So that's one of the ways that you can find the difference between your terms in a sequence. Now, let's talk about how do we actually do a equation. How do I make an equation for either of these? So the parent equation, the recursive parent function for an arithmetic sequence would go like this. I would have A1 equals always just my starting term value. And then I would have AN equal AN minus 1 plus D. And then if I want to simplify some of these terms, AN is my newest term. AN minus 1 is the term, is previous term. And I call that my old term. And then this D right here is my common difference. And the only difference between the recursive parent function for arithmetic sequences with the geometric, everything's going to be the same except this common difference, okay? So over here, if I wanted to come over my recursive parent function for geometric sequences is going to have the A1 equal my starting term. And then I'm going to have AN equals AN minus 1. But this time, this term is going to be multiplied by an R. And really, the only difference is this is my common ratio. Okay? So now we have two different parent functions. I think the last thing we need to do is actually plug in the examples, okay? So right here, my first term is 2, and I know my common difference is also 2. So the example equation, number 1 equation is going to be A1 equals 2, and then my AN equals AN minus 1 plus 2. That's done right here. Nice and easy, straightforward, because we know what all these values are. And then over here, my example equation, example number 2 equation would be A1, and what is my starting value here? It's also 2, and then I'm multiplying by 2, okay? So I have A1 equals 2, and then I have AN equal AN minus 1, all of that times 2. So really the only difference between an arithmetic and geometric sequence is that here I am adding 2 and here I am multiplying 2. So we need to remember that our geometric sequences are the ones that are multiplying, and our arithmetic sequences are the ones adding. I'll make one last hint. Arithmetic adds the common difference. Then we got this one, geometric. Geometric multiplies the common ratio. Okay? So that's what we got overall for our review on recursive sequences here. Hope that helps.